So here's my Rube Goldberg machine. First, I drop this little beautiful car over the inclined plane. Boom. It falls into the cup. This cup that gets the car goes down because of the weight, and this one goes up. When it goes up, it knocks out this lever and drops the ball. Then it goes down this inclined plane and hits this book. This book falls, hits the scissors, and the scissors cut the nylon. The nylon goes over this lamp and it's holding a ball. This ball will drop, make a little of movement. This ball will go down because of the movement, go down the ramp again and go down this book, hit this book, cut these scissors, like make the scissors cut the nylon. The nylon is going over this statue here, and then it will drop this log, well, this piece of wood that has like a pointy thing here, and when it falls it will pop the balloon with water. The balloon with water will go down here and boom, fill the bottle of water. This is my Rube Goldberg machine, and here are the steps. First step, the inclined plane. Our second step is the cups, the lever, the pulley. Then goes the lever with a fulcrum, the lever. So that's our third step. Our fourth step, inclined plane. Our fifth and sixth step, the scissors that count as a wedge and as a lever. Our seventh step, another pulley. When the scissors cut the nylon, this ball falls. So a pulley, that's our seventh. Our eighth step, an inclined plane here. Our ninth step. Our ninth and 10th step, another scissors, a lever and a wedge. And then our 12th step, another pulley that goes through the statue and releases the ball.
Muy bien.
Espera. In this beautiful machine, I have 4 or 5 simple machines. The first simple machine, an inclined plane. Yep, inclined plane. The second simple machine I have is the pulley. The pulley. Then I have the lever. I have another inclined plane, but that's I have the lever. I have 3 simple machines. Then I have the wedge and the lever, but so I have the wedge here. I have 4 simple machines. Going on, another pulley, another inclined planes, other wedge, another pulley, and I don't know if you are counting this as a simple machine, Miss Bonnie, but if you count it, I have 5 simple machines. When I'm lifting this car to the ramp, I'm having potential energy. When I put it in the ramp, I still have potential energy. When I release it, it loses potential energy and gains kinetic energy. Meanwhile, it goes down, it keeps losing potential, and it keeps gaining kinetic. Boom, this goes down, stops. Now, when he stops, he has no more, he has no potential energy and no kinetic energy. Here I'll be talking about Newton's 3 laws. So the first law: every object that is at rest or at motion stays like that until an unbalanced force acts upon it. So if this book is still, right? It's not moving, it's at rest. And the ball is at motion. The ball is in motion until an unbalanced force, the book, hits the ball. So here the ball stops moving and the book falls. So also the book is at rest until the unbalanced force, the ball, hits upon it and makes it fall. That's Newton's first law. Newton's second law is if it has more mass, it's difficult to move, I think. Newton's second law states that the acceleration of an object increases with increased force and decreases with increased mass. The direction in which an object moves is the same as the direction of the force. So, first, I was going to make this little marble hit the science textbook, but the science textbook had a lot of mass. So the ball couldn't move it. So I changed it by this much lighter book. So when the ball fell, it was much easier to move it than the science textbook. Newton's third law. And every action has a reaction, equal in size and opposite in direction. So, this ball is falling, right? And it's going this direction. Dun, 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 dun. Boom. And the book is pushing this side. So, when the ball hits the book pushes the ball, so it's making force to this side, so opposite in direction, and the size of the force put in the both objects was the same, so equal in size and opposite in direction. So this book will fall here and the ball will go there, and the force that the ball was going was this side and the book was pushing that side. The acceleration of the car in the same inclined plane by starting from here is of 1.2 meters per second per second. The acceleration of the car in the same inclined plane by starting from here is of 1.2 meters per second per second.